An early model for an atom considered it to have a positive charge point nucleus of charge Ze surrounded by a uniform density of negative charge up to a radius capital R. The atom as a whole is neutral. For this model, what is the electric field at a distance small r from the nucleus? Question mark. You can see in figure also the dotted line shows Gaussian surface 1 and 2, nucleus and atom. Here the nucleus of atom of an element with atomic numbers capital Z has total positive charge plus Ze, where plus E is the charge of one proton surrounding to this central positive point charge. Uniform volume distribution of equal negative charge was considered up to radius capital R as per the early model of neutral atom. If volume charge density of this negative charge is rho, then rho is equal to total negative charge in an atom upon volume of the spherical atom. Rho is equal to total negative charge in an atom upon volume of spherical atom. Rho is equal to Q upon V. Therefore, rho is equal to minus Ze upon 4 by 3 pi r cube is equal to minus 3 Ze upon 4 pi r cube. Equation 1. Now let us find out the electric field for following three cases. First, for Ri less than capital R inside the atom, consider spherical Gaussian surface with a radius Ri and surface area 4 pi Ri square. Magnitude of the electric field at any point on this surface is same because of the spherical symmetry. Let it be Ei. Here net charge enclosed by above Gaussian surface is small q is equal to capital Ze plus 4 by 3 pi Ri cube. Rho is equal to capital Ze plus 4 by 3 pi Ri cube in bracket minus 3 capital Z small e upon 4 pi capital R cube bracket over. From equation 1, small q is equal to capital Z small e in bracket 1 minus Ri cube upon capital R cube bracket over. Equation 2. Therefore, q is equal to capital G small e bracket 1 minus small Ri cube upon capital R cube bracket over. Equation 2. Applying Gaussian theorem for considered Gaussian surface, integration vector Ei dot vector ds is equal to q upon epsilon 0. Therefore, integration Ei ds cos 0 is equal to capital Z small e upon epsilon 0 in bracket 1 minus small Ri cube upon capital R cube bracket over. Here vector Ei parallel to vector ds. Therefore, Ei integration ds is equal to Z small e upon epsilon 0 in bracket 1 minus Ri cube upon capital R cube bracket over. Ei is constant. Ei in bracket 4 pi Ri square bracket over is equal to capital Z small e upon epsilon 0 in bracket 1 minus Ri cube upon capital R cube bracket over. Therefore, Ei is equal to capital Z e upon 4 pi epsilon 0 in bracket 1 upon Ri square minus Ri upon capital R cube bracket over. Equation number 3. Above electric field is directed radially outward. Above electric field is directed radially outward. Second, for small r 0 greater than capital R outside the atom, consider a spherical Gaussian surface with radius small r0 and surface area 4 pi r0 square. Magnitude of the electric field at any point on this surface is same because of the spherical symmetry. Let it be E0. Here net charge enclosed by above Gaussian surface is small q is equal to capital Z e plus in bracket minus capital Z e bracket over. Both are cancelled is equal to 0. Now applying the Gauss theorem to above Gaussian surface, integration vector E0 dot vector ds is equal to q upon epsilon 0. E0 is equal to 0. Therefore, q0 is equal to 0. Equation 4. Third, on the surface of atom in bracket small r is equal to capital R. If we consider spherical Gaussian surface with radius small r is equal to capital R, then the charge enclosed by it is also small q is equal to capital Z small e plus in bracket capital Z small e bracket is equal to 0, and so electric field on the surface of the atom is Es is equal to 0. From equation 3 also we get the electric field on the surface of the atom Es is equal to capital Z E upon 4 pi epsilon 0 in bracket 1 upon r square minus capital R upon r cube bracket over for small r is equal to capital R is equal to Z E upon 4 pi epsilon 0 in bracket 1 upon r square minus 1 upon r square bracket over. Therefore Es is equal to 0. Conclusion: at a distance Ri less than capital R from the center of the atom, electric field Ei is equal to Ze upon 4 pi epsilon 0 in bracket 1 upon Ri square minus Ri upon capital R cube bracket over radially outward. Second, at distance small r greater than or equal to capital R from the center of the atom, electric field is E0 is equal to Es is equal to 0.